Right, so let's have a look at these algebra questions on the test that we've done this week. So it's a lot of fairly straightforward questions, but the odd tricky one thrown in. So let's start off with question 1, where it asks us to find the g of g of 5. So we're given a function which is the g of x, and we're told what the limits on the domain are. And then we have to find the g of g. So just to remind you of this, we've got a composite function here. So what that means is we substitute the value here into the first function, and then whatever the output of that is substituted into the second function. So that's the first one, that's the second one. So we've got our input value x goes into our function g of x, and then whatever comes out of that goes into the second function. It's function 1, function 2. So because it's the g of g, then both functions are obviously the same, and you can see on my solution sheet that I've given you, I've worked out, I've substituted in, and we get 15 over 2 comes out of the function first of all, and we substitute that back into the function to get our second value, and our output is 40 over 9. Hopefully that's fairly straightforward. But what about b? Now b is a bit more tricky. Now in a question like this, it gives you a bit of a flag word here where it says state, and that says that you just need to write it down. You might need to think a bit, but no calculations are involved. And typically for a state question, there's 1 mark going for it, and that's what we've got here. It's a bit deceptive though, as you'll see from my solution. For that 1 mark, you might look at this and say, right, what's the minimum value of x? And x is going to be 5. So you could work out the range when x is 5, but then you need to decide where to go from there. So let's just remind ourselves, what do we mean by range? If we've got a function, we plot its graph. Now we don't know what the graph of this function is going to look like. Let's say it looks like that. So the initial x value is 5, and we're told x is greater than or equal to 5, so it includes that point on the line. And so the domain of the function, in other words the possible input values, they're those values. But what about the range? That's what we're after. Well, the range is the possible y values, or the values of the function. So we can work out that the point it starts at, where x equals 5, that in fact we've already worked that out in part A, it's 15 over 2. So that is 5, 15 over 2. But then, just with a function given to you, you don't know, does x increase, does it decrease? So to find out what the range of g is, you need to think, well, what happens as x increases? And in fact, as x tends to infinity, what happens is x gets bigger and bigger. That's what you need to know. So at this stage we're going past the 1 mark stage, and to do this it really helps if you can look at the function and say, well, what kind of function is it? Is it a transformation of a function that I know? And the way to deal with this, and this is a challenging one, is you look at the denominator, you look at the numerator, you compare them and say, how do they relate? And we see we've got the x's, we can compare the x's, got 2 on top, 1 on the bottom, and so we can say, well, we're going to somehow make 2 lots of the denominator in the numerator. And so you can see I've written it in your solution that I've given you, but we've got 2 lots of x minus 3. Now I need to make that equal to 2x plus 5, and so I say, well, if I multiply that out, that's 2x takes 6. How do I get from subtract 6 up to plus 5? And as you know, plus 11. I've not changed the denominator, the numerator is still equal. What this does mean is that we can say, let's split it into 2 fractions. First of all, considering the 2x minus 3 divided by x minus 3 gives us 2. I've not forgotten about the 11. We've still got the 11 over x minus 3. So what you do need to be able to do now, though, is to look at that and say, right, this is a reciprocal graph. What does a reciprocal graph look like? Well, it starts as you get close to the y-axis, it's very high, and then it does indeed go down like this. It never quite reaches the x-axis, but as x gets bigger, it gets closer and closer to the x-axis. And so you can see in the solutions that what I've done is I've said, well, as the reciprocal section of it, as x gets bigger, then 11 over x minus 3 will get 11 over a very large number, which is getting very close to 0. So as that gets closer to the 0, the whole function will get closer to 2. Just like the reciprocal graph on the x-axis, it will never quite reach 2, just like the reciprocal graph won't quite reach the x-axis. So this is a hard one, and I don't think that you'll get anything as hard as this in the exam, but you might need to relate a graph to a graph you know. So where do we end up? We know that the graph won't quite reach to 2. 2 will be an asymptote. And so so the range of G, it's got its maximum of 15 and then a minimum of 2, which it never quite reaches. So it's between 2 and 15 over 2. It does equal 15 over 2. It doesn't reach 2. Last part, finding the inverse function. This is actually a GCSE level question. It'd be a very hard GCSE level question, but it is work that you covered then. And to find the inverse function, we set y instead of g of x as equal to our function. Then we rearrange the equation until we've got x as a subject. And what we end up with is, and you can look at the solution if you want to know how I got there, we get that. So those should be y's, and then you swap the x's and y's over, and instead of a y you put your inverse function. We've swapped the y's for x's, and instead of the y we put the inverse function. We found the inverse function. We still need to state its domain. This is something that we seem to have forgotten or not revised. Now, when we've got a function, let's say the f of x, this is a general rule which holds good, and an inverse function, then the domains and ranges relate to each other. So if the domain of the f of x, let's call it a, then for the inverse function that becomes its range.